Alright, so here we are with the 5-6 notes. And we're talking about graphing and transforming rational functions. So, the idea of this, and hopefully you remember from our transformations unit, that we have this a value, that whenever it changes a certain number in a parent function, it will do things to that function. We've got this 1 over b, or b value, an h value, and then also a k. You may remember previously that when you had looked at it, you may have seen y equals a, and then this f of 1 over b times x minus h plus k. And so we're going to use this, but now our function, so notice this f here, is actually going to be 1 over x, because that is the parent function of a rational function. So from this parent function, if I've decided to put an a value in, up here for instance, that is going to vertically stretch or compress, depending on what the value is. And so we'll write that in here, vertical stretch or compression. And within that vertical stretch or compression, we're talking about a stretch being one to infinity, and then a compression is going to be those fractions or those decimal values of 0 to 1. And we are technically talking about the absolute value because it could also be a negative number, which we will talk about when it comes to flipping it. Alright, then we also have the b value here, and so if we look at our b value underneath here, that is going to be a horizontal stretch or compression. And so when 1 over b is a stretch, it's between 1 and infinity, and that's going to be a stretch. So we could also put 1 over b in for this a value, or we could put 1 over b in for this a value, and that would give us a compression as well. Alright. Then we also have our horizontal shift up and down. And remember, left or right. And remember that left is going to be if this is a positive value, and right is going to be if it's a negative value. And then our last piece here is k, which is going to be your vertical shift. And of course up is your positive and down is your negatives. From there we have if a is a negative or if b is a negative. And so if a is a negative, we're actually going to flip this across the x-axis. And then we're going to flip across the y-axis if it is 1 over b is negative. Alright. So, we're going to go ahead and find a graph a rational function, and then kind of talk about its transformation. So, the first thing that I'm going to do is actually graph the parent function, which is 1 over x. And so if I graph my parent function with this table here, and so if we go ahead and graph our parent function, we see that it's negative 0.3 repeating if we plug in a negative 3. negative 0.5 if we plug in negative 2, a negative 1, and then we actually get an error at 0, and we'll kind of talk about that in a second. And then it flips, and you get a 1 and a 0.5, and then a 0.3 repeating. So, the idea on this equation is if we graph it, let's see, negative 3, negative a third, and then 0.5, and then 1. And then this error actually means that it is an asymptote. So at x equals 0, we have an asymptote. And then it turns out you can't actually get 0 from 1 over something. And so that's actually an error as well. And so we have a second asymptote. And so when you think about how we'd graph this, we actually are graphing kind of these two ellipses here. And then the other one does the same thing. So we end up with over 1 up 1, but then over 2 down a half, and then over 3 down a third. And so, once again, our equation kind of takes on this ellipses shape. So, going ahead and graphing our transformed function, we're going to try to describe what's going to happen, and then actually graph it by hand to show. So, first thing here is a difference of 7 up on top. And so notice that we have a vertical stretch or compression if that value is replaced. So a has become 7, and so in that case 7 is definitely between 0 and infinity, and so we're going to have a vertical stretch. So this value of 7 gives us a vertical stretch. There is no value being multiplied by x, so we're not going to talk about horizontal stretching or compressing. But we do have an h value of 2. And so that 2 value, again, notice if we look at our directions, it's moving left if it's a positive, which it is, and it's moving right if it's a negative. And so in that case, we're going to talk about going left 2 units. And then our last one is that 9, negative 9. And that negative 9 is now a vertical shift up or down, and so in this case down 9 units. And then the last piece is the fact that it is a negative 7. And so because it's negative, it's actually flipped across the x-axis. And remember, this is our x-axis here. So, let's see. If we're going to graph this without necessarily doing the exact values, what I can see is that it's going to end up stretching, and so in that case it's actually going to kind of become closer to the axis than this green one. It's going to go left 2 units, which means that my asymptote is actually going to move left 2 units. And then it's also moving down 9 units, and so it's actually going to be down here. So instead of up here at the 0, 0, our new center is actually going to be down here. And then the last piece where it says it's across the x-axis, that means that instead of being up here on top, it's actually going to be down here and over here, because we're flipping both of these pieces from here across and here across. It's kind of a lot of writing there, but I'm going to keep those axes there as we go through it, and then I'm going to put our values over here in the y-axis. So, sorry, in this y column. So, if you plug in, again, we're just plugging in these values here, so plugging in negative 3. So plugging in with negative 3, we get a negative 2. Negative 2 is actually where we're going to get our error, meaning an asymptote. Negative 1 is actually negative 16. 0 is negative 12.5. Negative 11.3 repeating is here. Negative 10.75 here. And then our last one of negative 10.4. So if we go through and graph, there's not necessarily a lot of points that we have, but negative 3, negative 2 is one of the values, and so that's going to be here. And then after that, if we get closer, we get an error. We could potentially extend our table up a little bit more and maybe get that negative 4 was negative 5.5, etc. And so negative 4 is negative 5.5. And so you can kind of see that we are going down, then of course towards that asymptote. And then the other one doesn't actually even get to the axis. It looks like finally at around 6 we actually get to seeing it up here. But otherwise it is technically going down this way. So again, the idea is that we have taken this down 9 units and left 2 units to shift from 0, 0 to negative 2, negative 9. So now if we go through and identify our domain and range, remember that domain is talking about those x values that exist. And so if we think about how far left and how far right our axis goes, notice these arrows here, they're saying it's going all the way left and all the way right. However, right here at negative 2 is an issue, right? So we can say all real numbers, because it's going all the way left and all the way right, however x cannot be negative 2. The same thing is going to happen with the range, or the y values. And so in the range, again, notice that it's going all the way up and all the way down, but over here at negative 9, we're having an issue. So we're going to say, again, all real numbers, but y cannot be that negative 9. Then we have our horizontal asymptote, and so we have kind of talked about that a little bit, but that horizontal asymptote is y equals. All horizontal lines are y equals. And so that's going to be y equals 9 from that piece. And then the other one, the vertical asymptote, is x equals. And so x is going to equal this value that it's at here, which is negative 2. Alright, so what you're going to be expected to do is identify the fact that this is our parent function, and through each of these pieces, the a, the b, the h, the k, what happens to the original equation in green here that used to be at 0, 0, and now is probably going to be shifted up or down or left or right. So, on your assignment here, you can see that we've got the original parent function and then a plus 4, the original parent function with a few other 4's involved. Over here we've got some 2's in different places, and then we've got a negative and a 7 and a 5. So all you're going to do is do exactly what we did in the first one, where you're going to graph the parent function if you would like, but otherwise the actual function as well. Identify what each of those new values is doing to the function, and then of course give us our domain, range, and asymptote values.